Good morning, students. So the next molecule that we're going to go over in the Lewis structure lab is going to be the nitrite ion, which is NO2 negative. So for the first step on this one, we need to figure out how many valence electrons there are. So we're going to be looking at each each atom separately to figure out how many electrons it has. So N and O. So to that, we're going to look at the periodic table, and we're going to follow the trend that tells us that depending on what column it's in, that determines how many valence electrons it has. So for nitrogen, it's in column 5 if you don't take into account the d orbital. So it's going to have 5 valence electrons. And for oxygen, it's in the 6th column, so that's going to have 6 valence electrons. So I'm going to write those over here. Nitrogen's 5, oxygen is 6. So to be able to figure out how many are in total, we're going to put 5 plus 6. But then to take into account this 2, we are going to times 6 by 2. So there's 2 oxygens, thus there's 2 oxygens with 6 valence electrons. Now, we also have to take into account this negative charge. So what the negative charge tells us is the change in electrons for this molecule. So that means that this molecule has 1 extra electron compared to how many it will typically have. All right, so it will have 1 more electron than the neutral molecule would have. So to take that into account, we're going to put a 1 here so that we know that there's 1 extra electron in the molecule. So altogether, that gives us, actually, I'm going to just times that out so that I don't mess up. Okay, there we go. So altogether, we are going to have 18 for our total valence electrons. Okay, great. So for step 2, what we're going to do is we're going to look at our molecules and we're going to decide which one is going to be our central atom. So to do this, we're going to look at electronegativity. So if we look at our periodic table, we can tell that nitrogen is to the left of oxygen. And the trend is, if it goes to the right, it is more electronegative. To the right, more electronegative. And up the periodic table is also more electronegative. So with that, nitrogen is going to be less electronegative. Oxygen is going to be more electronegative. So with that, nitrogen is more likely to be our central atom. So for step 3, we're going to connect all of our atoms. So it's oxygen, oxygen, 1 bond here, 1 bond here. This is going to be our skeletal structure. And so I like to keep track of our electrons. So I'm just going to put how many we started with. And then there are 2 electrons here, 2 here. So in our bonds, we are using 4 electrons. So after we put all our bonds in, we now have 14 electrons. So for step 4, what we're going to do is we're going to put in our lone pairs. So we can put 6 on oxygen. That'll complete our octet for each of the oxygen. And we want to start on these exterior atoms. So we have 2, 4, 6, 8 oxygens around the, 8 electrons around the oxygen, thus completing that octet. So we have our octet filled for both of those. And again, I like to keep track of my electrons. So on this step, we start with 14. We just put 6 around 2 different oxygens. So we just used 12. So we only have 2 electrons left. And with those 2 electrons, we're going to now put them on the central atom. Sorry, I should have just dragged the other drawing. Okay, so 2 on the central. So now we're going to look at nitrogen. So nitrogen has 2, 4, 6 electrons around it. So it doesn't have a complete octet. Thus, we're going to move to step 5. So in step 5, what we want to do is we want to complete all the octets And how we're going to do that is we're going to do that by making double bonds. So we can tell that this oxygen has a complete octet, but nitrogen doesn't. So what we can do is we can move these electrons to make another bond, thus giving nitrogen and oxygen a complete octet. And we're going to draw it, and then we're going to double check. So this oxygen has 2, 4, 6, 8. Nitrogen has 2, 4, 6, 8. Okay, because we have 2 on each of those bonds. And then for the last oxygen, this one over here, you have 2, 4, 6, 8 electrons. So now we have a complete octet for each of them. So we're going to bring this down here, and we're going to try to figure out what the electronic geometry and the molecular geometry are. So to be able to do this, we need to look at the number of electron sets in our molecule. And we mostly care about the central atom. So for this one, it's going to be nitrogen. So with nitrogen, we're going to look at how many sets of electron groups it has. So it has, we're going to draw it here. So it has 1, 2, and 3. Now I know this has 2 bonds here, so a lot of people would think that would be 2 different electron sets. However, since they are both connected to nitrogen and oxygen, they actually make up 1 electron set. Okay, so with that in mind, we have 3 in total, so we are going to have a trigonal planar for our electron geometry. Now, for the next step, what we want to do is we want to find our molecular geometry. So to do this, we're going to look at how many lone pairs there are. So over here on our central atom, we have 1 set of lone pairs, so that's going to be here. And so due to that, due to this, we know that we now have a bent molecular geometry. Okay. So the next step is going to be looking at a 3D model. So to be able to do this, I like looking at MolView. And so MolView is a website that anybody can look up, and it's really nice because you can draw the molecule and then see it in 3D. As you can see over here, you can see it from all different angles. So our molecule that we just made is going to be nitrogen, oxygen, and oxygen. And then we're going to make 1 bond here, and then we're going to make a double bond here. And then I'm going to clean it up with this little broom so it looks nicer. Oops. Oh. Uh-oh. Okay, next. Okay, and I put that negative there just so that that accounts for the negative charge on the molecule. So now let's look at the 3D form. Oh. Oh, I put the negative on the wrong one. I'm so sorry, you guys. Let's try this again. So nitrogen, oxygen, oxygen. Okay. It's here. Then let's make it a double bond. And I was actually supposed to put the negative on this oxygen, so that should make it much better. Okay, good. This looks exactly like our dot structure, except for now we can look at it 3D. So without that extra electron pair, we can now see that it is a bent shape. And if the electron pair was here, it would show right here. But since this is a molecular geometry, we can see that it's bent. Okay, and that's going to be it for our nitrite ion.